Hi everybody, welcome to another video on course Algebra, section 3.1, quadratic functions. Our quadratic function is a function in this form x squared plus bx plus c, or in the vertex form a times x minus h squared plus b. Actually, it should be k. Right. And the graph of a quadratic function is called a parabola, and there is a vertical line that is an axis of symmetry of the parabola. So a parabola, we have the axis of symmetry. So the graph will be symmetric on that line and this line. So that is the graph of parabola and the axis of symmetry. The axis of symmetry intersect the parabola at a point called the vertex. So the axis of symmetry, that line intersect at this point called the vertex. As we see here, this is either the minimum point or the maximum point of the graph. And the vertical, the axis of symmetry is the vertical line, so the equation is x equal to something. Right. Now we go to more specific. If the equation is in the vertex form, of course, if a is equal to 0, then we don't really have the quadratic function. If it is in this form, the vertex will be h and k, and the axis of symmetry is x equal to h. Now we learned in section 2.5 that a standard x squared is just a parabola. Now the h and k here, just translation, it go h unit to the right and k unit up if h and k are both positive. So we just have the vertex originally x squared, and then we just move to h and k. H unit to the right and k unit up, assume h and k are positive. So in this form, we can get the vertex just h and k, and the axis of symmetry is h. Now, if we have the quadratic function in general form, it's just a polynomial degree 2. Of course, once again, a cannot equal to 0. If it is, then it's not a quadratic anymore. Right. And the vertex will be given by this formula, and axis symmetry is equal to x component of the vertex. So why is that? Now we can just easily just multiply this out and we'll see it. So we have f of x equal to a x minus h and x minus h, because that's what the x minus h square is, and then plus k. We multiply it out, keep the 8 x squared minus hx minus hx plus h squared plus k, and then multiply it out, ax squared. There are 2hx with an a, so minus 2a hx plus h squared plus k. Right. What we do now is ax squared x squared, so those terms matches, and then this term match with this term. So we have negative 2a hx equal to bx. And if we cancel the x on both sides, we have negative 2a h equal to b. And if we want to solve for h, divide by 2a on both sides, make it negative 2a on both sides, we will have h equal to negative b over 2a, which is exactly h negative b over 2a. Right. Certainly we can find solve for k too, but that's more complicated. So in that case, we just evaluate the function at that values. Once again, the h component or the x coordinate of the vertex is that. Also, if we look at quadratic formula, the negative b over 2a is where we don't have this. That is negative b over 2a. Right. And also the vertex is on the axial symmetry, so that's why this is equal to 0. So the axial symmetry is x equal to h, the same h, or x equal to negative b over 2a, which is the same as the x component of the vertex. And finally, we learned about this in section 2.5. If a is positive, the graph will not be a reflection. If a is negative, there will be a reflection across the x-axis. So just flip it upside down. So this one is a is negative, that one is a is positive. A is negative when it open down, and when a is positive when it's open up, negative, open down. So I will say if it's positive, it open up, and if it's negative, it opens down. And if it open up, there will be a lowest point, and that is the minimum, and if it open down, there's the highest point, which is the maximum, right? So positive is open up, and the vertex is minimum. When a is negative, it's open down, and the vertex is maximum. Right. So that's pretty simple and straightforward. Now let's look at some examples. For the function f of x equal to x squared plus 6x plus 5, does the graph open up or down? So the leading coefficient is 1, which is positive. So the graph open up. So we say the graph opens up because it's positive. I'll find the vertex. So the vertex, it is in the general form. So the vertex will have the two components, the x coordinate and y coordinate. The h coordinate is equal to negative b over 2a. So here we can say a is 1, b is 6, and c is 5. And we just substitute here. So negative b over 2a. So this is negative 3. And the x coordinate is equal to that. Now to find y coordinate, it is easy. We're just going to put negative 3 into x of the function. That gives us 9 plus 5. That is 14 minus 18 minus 4. Right? 14 minus 18 is minus 4. So the vertex will have the coordinate of x equal to negative 3 and y equal to negative 4. That is the vertex. And the axial symmetry will be the same as the x coordinate of the vertex. So this one is just x equal to negative 3. The formula is still the same, x equal to negative b over 2a. But it should be the same as the x component of the vertex. Right. We continue on next page. find the intercept. The intercept, there is x-intercept and there is y-intercept. For x-intercept, we let y go to 0, and we have the equation equal to 0. And I can factor would be x plus we have 5 and 6, so should be 6 minus 1 x plus, no, to add up to 6, so y 5 and 1, so I have x plus 5 0, x minus 1 is 0, x plus 1 is 0, sorry, so x equal to 5, negative 5, or x equal to negative 1, so we have negative 5 and negative 1, so the x-intercept will be negative 5, 0, negative 1 and 0, so we say x-intercept negative 5 and 0 and negative 1 and 0. That is the x-intercept. And for the y-intercept is where we let x equal to 0. So it's easy, we just substitute into the function y equal to, y equal to f of 0, so we have 0 square plus 6, 0 plus 5, so it just equal to 5, and the y-intercept x equal to 0, y equal to 5. Is the vertex the maximum or the minimum? Well, if it's open up, there will be a minimum. And now we sketch the graph. Now put all the components of the graph. First, the vertex is negative 3, negative 4. Should have the grid. X equal to negative 3, y equal to negative 4. So that is the vertex. And the additive symmetry and then we have the negative 5, 0 and negative 1, 0 and the y-intercept 0 and 5. So the parabola will go through those points. Yeah, so that is the graph. And we do have the x-intercept negative 5, 0 here, and negative 1, 0, and y-intercept 0 and 5. And when we sketch the graph like this, we can find the domain and range. Domain. It doesn't matter what we put in for x. The graph can take any value for x. So domain is all real numbers, or we just say negative infinity to infinity, or all real numbers. Or if we draw the number line, it will be the whole line. And the range. The range will be on the y values, it goes at the lowest negative 4 and up. So we say from negative 4 to infinity. Or if we draw a line, from -4 to infinity. Right, so it's straightforward. So in the general form, we just have the x component of the vertex, or the axial symmetry -b over 2a. Right. Let's look at another example. -x squared -4x, -x squared minus 4x minus 3. So there's a graph open up or down. So here we have a is -1, b is -4, and c is -3. A equal to -1, so it is negative. Of course, negative open down. And because of that, it will be a minimum. I'm sorry, a maximum. Yeah, it's open down, so there will be the highest. There will be the highest point, so that will be a maximum. Right. So it's open down, and there will be a maximum. Right. The vertex. Vertex will have two components, or two coordinates. The x coordinate is -b over 2a. So -b -b over 2a. b is -4 and a is -1. So on from that, we end up with -2. So that is the x coordinate of the vertex. The y coordinate of the vertex is just equal to the values of the function evaluated at -2. So I'm just going to put -2 in here. Right. So that is -2 squared is 4, so -4 plus 8 minus 3, so 8 minus 7 is 1. So the vertex, we have x is -2, y equal to 1. And the axial symmetry, it will be the same as the values, the x values of the vertex, or the x coordinate of the vertex. So we just have x equal to -2. Pretty much the same formula, -b over 2a. And that's very important. That's what we need to remember in this section. Right. X-intercept, we have x intercept and y-intercept. For x-intercept, let y equal to 0. So we let the function equal to 0. And then we just solve for it. I will divide -1 on both sides. So divide by -1 on both sides. All of this turn to positive. And we will have the factor of x plus 3 and x plus 1. So we have x equal to -3 and x equal to -1. So the x-intercept -3, 0 and -1, 0. For the y-intercept, I will let x equal to 0. So y equal to the function when x equal to 0. So that's just -3. So the vertex is x equal to 0, y equal to -3. Let's grab all the component. Oh, we did say that the vertex is the maximum. Right, let's grab all the component. Right, when x equal to 0, y equal to -3. So I have a point x equal to 0, -3. The y-intercept. The vertex x equal to -2, y equal to 1. So it's about here. And -3, 0, -1, 0. Those are the x-intercept and the axial symmetry. So we have a parabola that open down like that. And from the graph we can determine the domain and range easily. Domain we own x values. X can be anything. No restriction because we do not divide by anything, or we do not have anything under square root. So x here can be anything. So again, -infinity to infinity, all real numbers, or that, or we just say that for all real numbers. And then the range, we have the maximum, therefore the y values can get up only up to that point of 1. So we go from -infinity to 1, including the 1, or we graph -infinity to 1. Right, so simple enough. Let's look at one more example. This time we have the equation in the vertex form. And so in the vertex form, is a x minus h square plus k. So in this particular example, a is equal to 2, h is equal to 1, and k is equal to -2. Right? Yeah, a is 2, h is 1, and k is -2. Just match that with the form of the equation, the function. Right. Now a is 2, which is positive. Positive. The graph open up. And therefore there's the lowest point, so that will be the minimum. Right. Now find the vertex. Now the reason this is called the vertex form is that we do have the vertex directly from here, which is h and k. So the vertex is just h and k, which is 1 and -2. Axial symmetry will be the x component of the vertex. X-intercept is where y equal to 0, and y-intercept is where x equal to 0. So we have 2, x minus 1 square minus 2 equal to 0. Right, for this one, of course we can multiply it out and solve it, but I will not do that. It will be more convenient. I'm just gonna keep the square and then divide by 2 on both sides. So if x minus 1 square equal to 1, and then we can take square root on both sides. If x minus 1 equal to, remember every time we take the square root on both sides, there's a plus or minus. And then we just have x minus 1 equal to plus or minus 1, and plus 1 on both sides. If x equal to plus or minus 1 plus 1, so we have the plus 1 is 2, and the 1 minus 1 plus 1 is 0. Right? So we have the x-intercept, x equal to 2, y equal to 0, and x equal to 0, y equal to 0. And because we have 0, 0, that also the y-intercept. So if we put 0 in for x, 0 minus 1 square is 1. 1 times 2 minus 2 is going to be 0. So because we have the 0 and 0, that also the y-intercept. Yeah, because the x component is equal to 0. Yeah, so in this case we just find the x-intercept and happen to find the origin, which is the y-intercept. So x and y-intercept is here, then 2 and 0. The vertex 1 and negative 2. Axiom symmetry, x equal to 1, so the vertical line x equal to 1. The reason I draw the dashed line here, because that's not part of the graph. And at negative 2, so that's the vertex, and the graph open up. So that is the parabola. Sketch the graph and then find the domain and range. So the domain x on real numbers, and then the range we have the minimum, so the range will go from the minimum and up, so go from negative 2 to infinity. Right, of course we can graph that as well. Alright, so when in the vertex form, we have the vertex. When it is in the general form, of course we can also find the vertex. And from a vertex form, if we want to change to general form, we just multiply it out, and when we simplify, we have a general form. But how do we go from a general form to the vertex form? So how do we go from here to the vertex form of a x minus a squared plus k? That's what we want. Right. The other way is easy. Just multiply it out. We should get the left side. So what we do here is we try to make a square. And if we want a square, that of course complete a square. So this is the process that we'll do. First, from here I will factor out a 2. From x, the plus 3 will stay there, because in the vertex form there's a constant stand out at on the back. So if you put out the 2, don't factor out the x, just factor out the 2, the leading coefficient. So a is going to be 2. Well, that's good. Now we have x squared plus 2x. That's where we factor out the 2 and 4 when we factor out 2. Right. Now we do the complete thing square. If we do the complete square, we need to add something here. And we cannot just do that. We add something to make a square, we have to subtract something to keep it balanced. We cannot just add something into the equation. Right. So what do we add? Remember, in completing square, we will take half of this number and then we square. Half of that is plus 1. Square is going to be 1. So we're going to add 1 here. Now, if we add 1, we have to subtract something. We're not going to subtract 1. The reason is because we have to multiply by 2. So we do add 1, but times 2, we actually add 2. So we have to subtract 2 to keep it balanced. And finally, the perfect square trinomial here will turn into just x plus 1 square. There's a 2. And then minus 2 plus 3. So with that, we convert this to a vertex form. Right. Same thing here for this function. Factor out the leading coefficient from the first two terms. This is just a negative. And we will have x squared minus 4x. And we do completing square again. We'll add something. And subtract something to keep things balanced. And then plus the last number, right? So completing square, half of the middle term, and then square. Negative 2 square is going to be 4, so we're going to plus 4. We cannot just plus 4 and then subtract 4 because there's a minus. We actually plus 4 but multiply by negative 1, so that is actually minus 4. So if we minus 4, we have to minus 4 to keep things balanced, or we can plus 4 to keep things balanced, if you will. Right, and then the perfect square becomes just x minus 2 square, and there's a negative here, negative, negative, so that 4 plus 2 is 6. Right, so that is where we go from the general form to the vertex form. From the vertex form to the general form, the other way around is easy. Just multiply it out and then simplify. We should get back to that form. Right, now let's do some applications. A baseball is thrown upward from the top of the building is modeled by this function, where s of t is the height of the baseball in feet and t is in seconds. How many seconds does the ball reach its maximum height? So this is thrown upward from the building. Say we have a building here, and the baseball is thrown upward, and it will come down. Right? At the highest point, that is where the vertex is. Now, if we graph that in terms of t, this is a quadratic function, so it will go like this. The vertex is where at the highest point, because a is negative, right? So the graph, this is a parabola form of quadratic function. So graph opens down. Therefore, we do have the maximum here, right? And the maximum at the vertex. So we say maximum at vertex, meaning we have to find the vertex. And this form, the vertex, the x component is equal to negative b over 2a. So 64 negative, and then 64 over 2a. So 64 over 32 is 2, negative, negative, so that is just 2. So what it means is, I should write t instead, because the function is in terms of t. So I change that to t. So that means after 2 seconds, the ball will be at the highest point. So after 2 seconds, the ball is at its highest point. Alright, and what is the maximum height? Now it's easy. We know it takes 2 seconds to get to the highest point. We're just going to put 2 in for it. Right, so we have negative 16 times 2 squares 4, so it's negative 64, and 64 times 2 is 128 plus 100, so that's 164. Right. If you have a calculator, it is rather simple. We just say 2 is equal to x, so 2 store into x, and then evaluate negative 16 x squared plus 64x plus 100. That's 164. Right. How long until it hit the ground? Well, it will hit the ground when height equal to 0. Well, that's obvious, right? So meaning that we're going to let this function equal to 0. And we just solve for t. Right. And to solve for 0, solve for t, make this equal to 0, solve for t. Look like all of them divisible by 4. So I'm just going ahead and do that. Negative 4 will be even better. So that gives us 4t squared plus 16t plus 25 equal to 0. Right? So here we can try factor, but I'm just use quadratic formula. Negative b but when we divide by the negative number, that gives us negative and negative. Right, so negative b plus or minus b squared minus 4ac over 2a. Right, so we have 16 plus or minus square root. Just use a calculator. 16 square or negative 16 square is still the same. Minus 4ac. So 656 over 8. Right. Do we have square root for that? No, it's not coming out anything nice and even. So we, in that case, we just evaluate two scenarios where we have 16 plus square root of 656 over 8. So that is one of them. If we do that, I will just use fraction here, and then 16 plus square root of 656 divided by 8 by 5.2. So it is about 5.2 seconds. And then if we use the negative minus, because this plus or minus, right? All I do is just go up there, highlight, and hit enter. Change to minus. And it's good. It's negative 1.2. So what we find here is the x-intercept on the when y equal to 0. Notice that this we talk about time, right? Time cannot be negative, so this is not a solution. Right. One way to check it is think about this. We throw it from here 100 and it reaches the high and it goes like this. So here roughly is about t equal to 5.2. Now we do have the vertex is at 2, right? So that's where the vertex at. Now that's what the graph is. Because if we go back in time, the vertex is at negative 1.2. But of course we're not gonna do that. We throw from the top of the building. If assuming that equivalently, if we throw from the ground up in that, it would travel the same trajectory. Right. One thing though, a way to check this is t equal to 2, where the vertex at, or t equal to 2 is the axial symmetry. So it will be symmetric from that point. So there's 3 units, 3.2 units to go from here to there. And then 3.2 units from here to there as well. Yeah, because here we have 16 plus square root of 656, and then this minus square root of 656. If we don't have the plus or minus, we just have 16 over 8, which is just 2. So, one more thing. The axial symmetry. The x-intercept always symmetric on the axial symmetry. Right. Next. This one. A developer wants to build a rectangular range next to a river, and if he has 6,000 feet of fencing and he does not need to fence the side of the river. So at the river bank, and we're trying to build a rectangular range. On the side of the river. What is the largest area can be enclosed? So this is rectangular. So let's say this is x. This would be y. By the way, assume that the river bank is straight. It's not kind of curvy. Or assume that it's perfectly straight. So it will make a rectangle. Right. So we try to find a maximum area here. Right. So what do we have? That would be 6,000 feet of fencing. So x plus y plus x is equal to 6,000. Right. Now, that gives us 2x plus y equal to 6,000. Combine our terms. And if we subtract 2x on both sides, we have y equal to 6,000 minus 2x. And from there, can substitute into y. That's 6,000 minus 2x. And then the area which we're trying to maximize is just x times y. Length times width, pretty much. So then we have the area y is equal to 6,000 minus 2x. Multiply it out, 6,000 x minus 2x squared. Or we'll rewrite negative x squared plus 6,000 x. Right. Now, this is a quadratic function. A is equal to negative 1. It's negative, so it's open down. And there will be a maximum at the vertex. Right. So since we find the largest area, we're just going to find the vertex. So the vertex x equal to negative b over 2a so 6,000 divided by 2, negative, so that's 3,000. Except I forgot the 2 here, right? Sorry. So a is negative 2. Still open down, still have the maximum at the vertex, so this will be negative 2, sorry. And 6,000 divided by 4 is 1,500. Now, so we have x equal to 1,500. Substitute in for y, we certainly can solve for y. 6,000 minus 2 times 1,500. So that will be 3,000. So y is equal to 3,000. What we have x, we have y. The area is x times y. That will give us the largest area. Right. Bottom line is because we do have a quadratic function that opens down, that the graph opens down, so the maximum will be at the vertex. And so we have the vertex x component is 1,500. This question asks for the largest area, so the area would be just put 1,500 back into this function. Right. Store into x, and we have negative 2 x squared plus 6,000 x $4,500,000, and that fit so will be a square feet. Of course, if we can take 1,500 feet times 3,000 feet, we have the same thing. Right, so and when we have the application for this problem, and that also concludes section 3.1. Thank you for watching. See you in another video in college algebra.